So last week we didn't manage to complete all the questions, right? We stopped at, we finished question 8, then we didn't go on to question 9. And that was because we had to do quite a bit of the learning. Okay, so now we continue with this. Right, I'm not going to be like flashing your answers as we go along. Okay, I need to complete this worksheet and then start the next one. Yeah, so we have question 9 and 10 left. Not too difficult actually. So if you look at question 9, elements beryllium, magnesium, and calcium are placed in group 2 of the periodic table. Now, the information here, right, for example, saying that they're alkaline earth metal at your level, you don't need to know yet. But when you are learning the periodic table not next year, it should be in Sec 3, okay, you need to know group 2 elements has a special name. It's called alkaline earth metals, okay? So that's their special name. Like the noble gases is in group 0, right? Yeah. So group 0 are known as the noble gases, group 2 known as the alkaline earth metals. So what about the group 1? Group 1 are called alkaline metals, okay? So then group 3 don't have, group 4, 5, 6, 7, there is 7, we call them the halogens, okay? But you will come across these terms only when you do periodic table in Sec 3. So why is it that they are actually placed inside group 2? Before I start going into part 1 of the question, maybe I ask you, do you recall what I said about the various groups or not? Do you recall? I told you why, remember we were doing group 1 and then we are looking at the electron shells, okay, like sodium. Sodium is 2.8.1, right? Because first shell takes 2 electrons. If I write down for you, maybe it's easier to see. Okay, so we talk about sodium last lesson. First shell takes 2 electrons. Second shell takes 8 maximum. Okay, then you have 1 electron left in the third shell. Correct enough. So after that, we realize that sodium is actually inside group 1, right? So if it's in group 1, okay, then we see something very, very striking to us here. Okay, what is it actually? Try to look at the other elements in group 1. Do you have your periodic table with you? Check out lithium. Lithium is actually above sodium. So if I write a bit smaller, lithium here, okay, check lithium. How many electrons does an atom of lithium have? How many? Correct. You are right. Okay. LeBron, you're right. Okay. I'm actually answering the second question that you are asking. Third question you're asking. Okay. Atoms usually have 2 electrons in the first shell. Okay. So if you check lithium, it has 3 protons, right? 3 protons also mean that it has 3 electrons because for all atoms, the number of protons and electrons are the same. So in this case, it will be 3 electrons. 2 will go into the first shell, left with 1 goes into the second shell. Next, okay, after sodium is potassium. Okay, 19 electrons. First shell takes 2, second shell takes 8. Third shell also takes up to 8. Okay, when you go to JC level, these things can change. Okay, don't ask me why now. Okay, so don't ask me why now because you're not supposed to learn yet. It can be confusing. Now, so if you count the number of electrons that I have already put into the various shell, it's still going to be left with just 1, right? So it goes into the 4th shell. Okay, rubidium, cesium, francium, you don't have to know whatever is inside. Clear? Okay, you don't have to know whatever is inside, but you need to know, all right, for rubidium, right? It will eventually end up to have 1 electron in the outermost shell. Okay, then I know some of you like Harvard will try to draw the electron shells, right? First shell takes 2, second shell takes 8. And how do we end up with 1 in the outermost shell? Okay, yeah, you don't have to know this, but you only need to learn to draw electronic structure for the first 20 elements. So you look at the proton number, okay, to determine the first 20, meaning you only learn how to draw up to calcium. Can you all see that? Beside potassium, do you see calcium? Okay, the periodic table, beside potassium, 19, right? Then calcium is 20. You only draw up to that for O level, for secondary school level. That's about it. Now, so do you see a certain trend? Do you see one here, okay, for the last shell? If I were to highlight, can you see that? Okay, so what makes them be placed in group 1 is actually because of their outermost shell. Okay, in the outermost shell, the number of electrons will actually determine which group they are in. You can write down notes if you wish to. Okay, it will be quite useful. All right, so outermost shell only 1. Okay, so meaning the group 1 elements and now I'm talking about group 1. Later you can move to group 2. All right. Another way of saying it is they all have 1 valence electron. What's the meaning of valence electrons? Okay, they are actually electrons in the last shell. The last electron shell, valence electron. From now on, you must remember this term. Very important term because it's going to be seen, it's going to appear all the time. Okay, you don't have to know how many electrons in the inner shells after 20 elements, meaning the 21st elements and so on, right? You don't need to draw the inner shells anymore. Clear? It's only up to 20 elements. Can? Okay? Yeah, because students are asking, so I have to let you know. Only the first 20, you need to draw the full electronic structure. Okay, so let's try group 2. Okay, so let's look at group 2. Group 2, definitely we will be thinking that, there should be 2 valence electrons, right? So let's try to show that this is correct. What is the first element in group 2? Can you see beryllium? Okay, beryllium has how many electrons? There should be 4, right? Because 4 protons equal to 4 electrons. So first shell takes 2, second shell takes 2 also. Followed by magnesium. Magnesium is a 12. Okay, so 12 electrons. So you have 2 electrons in the first shell. Second shell takes 8. Okay, and then followed by how many electrons in the third shell? 2. Correct now. Okay, so 2 and 8 makes 10, 10 and 2 makes 12. Okay, that's correct. Followed by calcium. Okay, calcium is 20. 20 electrons, first shell takes 2, second shell takes 8, third shell takes 8, and then left with 2. So do you see there are like 2 electrons in the outermost shell? So the 2 valence electrons is actually telling you they are in group 2. Okay? All right. So far, still okay? Still okay, huh? Do you all have question about the group 0? You are okay with group 0, right? Fully filled. Okay, why is it that it's group 0? Yeah, group 0 are the noble gases. Do you know why it's put as group 0? Okay, now in the past, a long time ago, tell you some history. I was taught that we call it like group 8, okay? Because we are looking at the neon, okay, which is 10, so it's 2.8, and then argon is 2.8.8. So the number of electrons in the outermost shell is 8, right? Then somebody started asking, but helium has only 2. Helium has only 1 shell, and it's 2. That cannot be 8 electrons in the outermost shell. So they decided to change this. No more calling it 8. We call it 0. Why 0? Then you'll be asking, why 0? How come not 2 and not 8, but 0? It cannot be 2 because 2 is already used for group 2. It cannot be 8 because helium doesn't have 8 electrons in the outermost shell, right? Yes, correct. So you have to think about, they don't have the electrons in the outermost shell that needs to be given away, all right? Or whether they need to take in any more of them. Yeah, correct. So they say group 0 means that we call them 0 valence electrons. Why 0 valence electrons? Because it is not necessary for them to take in or give away electrons. Can you understand better now? So valence electrons are termed as valence electrons for a reason, meaning they are not fully filled. There is something that they need to do, some activity, some reaction they have to take part in. Can? Okay, so for this part here, understand better. When you study periodic table in future, you will find that it's easier. Okay? So we come back to this question now. This question really didn't have any link to all this, but okay, which noble gas has the same number of valence electrons? I wouldn't even call it valence electrons, okay? Yeah, as a beryllium atom. But even if they say it this way, you just accept that it's the last shell, okay? So you look at beryllium, valence electrons is actually 2, correct now? So which noble gas has the same number here, 2? Definitely, the answer will be helium. Okay? Simple as that. All right? Yeah. So periodic table, okay, just a quick recap. All right. Now, you know hydrogen, right? I think I mentioned to you before, I will explain to you why hydrogen is floating here. Because hydrogen has only 1 electron, right? Correct? So hydrogen has only 1 electron. So there's only 1 shell and 1 electron there. I cannot put hydrogen here. Valence electrons is 1, right? But it cannot be there because this is a non-metal. Understand now? But I can't put it anywhere on the right-hand side because there's no place for hydrogen. Do you see that if I put it here, it becomes group 3? If I put it here, it becomes group 4. So none of this position can take in, hydrogen. So that's why it is placed here floating on its own, because it is a non-metal with 1 valence electron. That's all right. Don't worry about LeBron, don't worry about them using valence electrons. You just take it as it is for now. Okay, at higher level, you are definitely going to learn the correct terms. Okay, so I hope I have explained this part about hydrogen. I promise you I'll talk about it. Yeah, so at least I show you now why hydrogen is there. Okay, and then this is the first period. We talk about